Right now, you're resting on is stable planet. Not because anyone is paying attention to it, not because it's being carefully managed or held together moment by moment. It's stable because of conditions that have been in place for a very long time. Conditions that change slowly. So slowly that a single night barely registers against them. You don't need to maintain that stability. You don't need to think about it correctly. It doesn't depend on awareness. Earth has been moving through space for billions of years, and during that time, it has remained within a narrow range of behavior that allows surfaces to stay intact, orbits to remain regular, and long-term patterns to persist. That isn't something that started recently, and it isn't something that's about to end. For most of Earth's existence, no one was here to observe it. No one was listening. No one was worried. And still, the same basic physical processes continued, quietly, reliably. Tonight is no different. As you rest, Earth continues along its path, not hurried, not delayed. The ground beneath you doesn't need to be monitored to remain where it is. The motion of the planet doesn't require supervision. The conditions that keep it stable don't require intervention. They operate whether you're awake or asleep. It's easy to forget that stability doesn't mean stillness. Things can move continuously and still remain steady over long periods. In fact, that's often how stability works. Motion that repeats, forces that balance out over time, patterns that don't depend on exact precision, only on consistency. Earth doesn't stay stable because everything is frozen in place. It stays stable because changes tend to be gradual, because adjustments unfold across spans of time that are far longer than a human lifetime. That's not something fragile. It's something deeply established. When people talk about planets, they sometimes focus on dramatic events, impacts, sudden shifts, rare disruptions. But those moments are exceptions. They stand out precisely because most of the time, things proceed in a regular way. Most of Earth's history has been uneventful in that sense. Long stretches where the same fundamental processes continued without interruption. That's the part that often goes unnoticed. The long continuity, the reliability. Right now, nothing needs to change for you to be safe where you are. Nothing needs to be corrected. Nothing needs to be rushed. The planet has remained within stable bounds for an amount of time that's difficult to picture. Long before modern life, long before any written record. And it has done so through ordinary physical behavior, not through careful tuning, not through constant adjustment. Gravity acts the same way tonight as it did millions of years ago. Orbital motion follows the same rules it always has. Internal processes continue at rates that don't depend on what time it is on a clock. Those systems don't speed up because someone is anxious. They don't slow down because someone is tired. They simply continue. That's important because it means stability doesn't require vigilance. It doesn't require effort. It doesn't require perfect conditions. It's something that emerges naturally when large systems settle into long-term patterns. Our Earth is one example of that. A planet that has remained within a stable range long enough for oceans, continents, and atmospheres to persist. And tonight, that same long-term stability is still in effect. You don't have to hold yourself tense in order to stay balanced. The planet isn't asking anything from you. You can let your muscles loosen a little. You can let your attention drift. Nothing important will be missed. The idea that everything is constantly on the verge of collapse doesn't match how planetary systems usually behave. Most of the time, they change slowly. They drift rather than jump. This doesn't mean nothing ever happens. It means that when change does occur, it typically unfolds over spans of time that allow systems to adjust. That kind of change leaves room for continuity. It leaves room for rest. As you lie here, Earth continues its steady motion through space. That motion isn't new, and it isn't temporary. It has been happening for so long that it defines what normal means at a planetary scale. Tonight is just one more moment inside that long pattern. You don't need to measure it. You don't need to keep track of where you are. Your location, your position, your timing are already part of a system that has accommodated far more variation than a single night of rest. There's a certain comfort in realizing that stability doesn't require constant attention, that the systems supporting this moment are not delicate. They've been operating through eras of change, through shifts that took millions of years, through conditions that look dramatic only when compressed into short summaries. From within, those processes are quiet, and from here, from this moment, they don't demand anything from you. You can allow yourself to feel supported without needing to understand every detail of how that support works. Understanding can come later, or not at all. Stability doesn't depend on explanation. Earth doesn't need to be constantly reassured to remain on its path. It doesn't require encouragement to continue behaving as it has. It simply does. And because of that, you can rest without needing to brace yourself. As your breathing slows, nothing about the planet's behavior needs to adjust in response. As your thoughts drift, the long-term conditions remain unchanged. There's a steadiness here that doesn't rely on precision, a steadiness built from repetition and duration. Over very long spans of time, systems like this tend to settle into ranges where extreme shifts are uncommon, where most change is incremental. That's not a promise, it's an observation, and observations like that don't need to be acted on. They can simply be noticed or allowed to fade into the background. You're resting inside something that has been stable for a very long time. Long enough that tonight doesn't stand out. You don't need to keep watch. You don't need to stay alert. The planet will continue to do what it has always done. And in the moments ahead, if curiosity arises, it can do so gently, not as concern, just as quiet interest. Because once you realize that stability is already in place, it becomes easier to wonder how that stability is possible at all. That steadiness we talked about doesn't come from a short moment. It comes from time. Not the kind of time measured in hours or days. Not the kind that moves quickly or asks for attention. Planetary time moves differently. When we talk about planets like Earth, we're talking about processes that unfold across spans so long they don't feel dramatic from the inside. They feel ordinary. They feel expected. Earth has existed for billions of years. That number can sound large at first, but for a planet, it isn't unusual. It's simply the scale at which planets operate. Rocks form and change across millions of years. Orbits repeat across hundreds of millions of years. Internal processes unfold steadily across billions. None of that is rushed. None of it needs to be. When Earth moves through space, it doesn't do so on a schedule that reacts to short moments. Its motion is guided by long-term patterns that have been repeating for a very long time. From a planetary perspective, tonight is brief. So brief that it blends seamlessly into what came before it and what will come after. That isn't meant to make this moment feel small, it's meant to make it feel safe. Because when systems operate on such long timescales, sudden change becomes rare. Most adjustments happen gradually, so gradually that continuity remains intact. Geological time works the same way. Mountains rise and erode across spans that stretch far beyond any single lifetime. Surfaces shift, layers settle, materials move slowly. Nothing about those processes depends on quick reactions. They aren't sensitive to short interruptions. They continue whether anyone is watching or not. When scientists talk about Earth's history, they don't describe a series of constant emergencies. They describe long intervals of relative consistency, punctuated by changes that unfold over extended durations. That pattern is important. It tells us that stability is not a fragile condition. It's the natural outcome of systems that have time to settle. Earth has had that time. Billions of years of repetition have allowed motions to smooth out, have allowed internal and external processes to find steady ranges. That doesn't mean nothing ever changes. It means that change usually arrives slowly enough to be absorbed. Right now, nothing about the planet is being hurried forward. Nothing is being accelerated by this moment. The passage of time at a planetary scale is even, steady, consistent. It doesn't respond to urgency. It doesn't speed up because of concern. It simply continues. And because of that, the present moment doesn't carry extra pressure. It doesn't need to resolve anything. Earth has experienced periods far more different from one another than tonight is from yesterday. And still, so the same fundamental structures remained, the same general motions, the same long-term balance. That's what deep time allows. It allows systems to adjust gradually, to distribute changes across long intervals rather than concentrating them. When you think in those terms, it becomes easier to relax inside the present, because nothing is asking to be rushed. The planet does not operate on deadlines. It does not move towards sudden endings. It moves through long stretches of continuity. That continuity doesn't require attention to function. It doesn't depend on awareness. It existed long before anyone was here to notice it, and it continues now, quietly. As you rest, you are inside that same long timeline, a moment that fits naturally into a much larger sequence. There is no need to hurry through it. No need to anticipate what comes next. From a planetary perspective, there is plenty of time. Time for motion to repeat, time for balance to hold, time for gradual change to unfold without disruption. That's why stability doesn't feel tense at this scale. It feels settled. Earth's long history is not a story of constant instability. It's a record of persistence, long spans where conditions remained within familiar bounds, long stretches where fundamental behaviors repeated again and again. Those repetitions are not boring, they are stabilizing. They allow systems to remain predictable across vast durations. And predictability at this scale does not require precision. It requires consistency. That consistency has already been established. It has been reinforced across billions of years of motion, rotation, and internal adjustment. Tonight doesn't stand apart from that history. It fits neatly inside it. Nothing about this moment is out of sequence. Nothing is arriving too early or too late. The planet has experienced far longer nights than this one, and far longer days. From its perspective, time moves smoothly, and because of that, you don't need to compress this moment into something productive. You don't need to make use of it. You can let it unfold at its own pace. Deep time doesn't demand attention. It doesn't reward urgency. It simply continues steadily. And as you become familiar with that idea, even quietly, it becomes easier to accept that change, when it happens, doesn't arrive all at once. It arrives slowly, predictably. That long stretch of time we talked about has another important effect. It changes how change itself behaves. When processes have a lot of time available, they don't need to hurry. They don't need to arrive all at once. They can unfold gradually. On a planetary scale, that gradual unfolding is the norm. Most change does not arrive suddenly. It accumulates. It spreads out across long intervals. From the inside, that kind of change often feels almost invisible. Not because nothing is happening, but because it's happening at a pace that allows continuity to remain intact. Earth has been adjusting to small variations for billions of years, not through abrupt shifts, but through slow responses that balance out over time. When conditions change slightly, the planet does not react immediately. It responds across long spans, allowing effects to distribute rather than concentrate. That's one of the reasons stability persists. Slowness at this scale is not a delay, it's a stabilizing feature. When systems move slowly, they have time to settle, time to absorb variation, time to adjust without disruption. This is very different from the way change often feels in daily life. But planetary processes are not designed to respond to short-term signals. They operate within ranges that have been reinforced over immense durations. Geological layers form gradually. Surface features evolve incrementally. Internal processes shift at rates that are measured across millions of years. None of this requires rapid correction. Instead of sharp turns, there are gentle trends. Instead of sudden jumps, there are slow transitions. That kind of behavior makes extreme change uncommon. It doesn't mean nothing ever changes. It means that when change does occur, it tends to arrive in a way that preserves continuity. Earth's long history reflects this pattern. Extended periods where conditions remain within familiar bounds. Gradual shifts that unfold slowly enough to be integrated. From within those processes, there is no sense of urgency, no signal that something must happen immediately. The planet does not rush to meet outcomes. It moves through sequences that have time built into them. That's why stability and change are not opposites here. They work together. Stability provides a framework. Change unfolds within it. This is important because it means you don't need to be alert for sudden transitions. There is nothing approaching that requires anticipation. The long-term systems that shape planetary behavior do not operate on surprise. They operate on repetition and adjustment. Over time, small influences average out. Short-term variations blend into longer trends. This averaging effect is another reason sudden disruption is rare. When change is spread across long intervals, no single moment carries excessive weight. No single night becomes critical. Tonight is one of many. It fits easily into the broader sequence. The planet does not need to respond quickly to remain balanced. It does not rely on immediate reactions. That gives it resilience. Resilience built from time, from patience. When you look at planetary history this way, the absence of urgency becomes clear. Nothing is pressing. Nothing is counting down. Change unfolds at a pace that allows stability to remain intact. And because of that, there is no need for vigilance. You don't need to monitor conditions. You don't need to stay prepared. The systems responsible for long-term balance adjust on their own timescales. They don't ask for intervention. They don't signal distress through sudden motion. They simply continue. This continuity allows Earth to remain within stable ranges even as gradual change occurs. The two are not in conflict. Slowness is not a weakness here. It's what makes long-term balance possible. When adjustments take time, they can be absorbed without disruption. They can settle into new steady patterns. That's how planetary systems maintain regularity across billions of years. Right now, nothing is accelerating. Nothing is compressing into this moment. The present is not under pressure from the future. It is part of an extended flow that has room for rest. You don't need to anticipate what comes next. You don't need to prepare for sudden shifts. The processes shaping Earth do not operate on short notice. They move gradually, predictably, and consistently. That predictability doesn't come from rigid precision. It comes from repetition across long spans of time. Patterns that repeat long enough become reliable, not because they never vary, but because variation is spread out. As you rest, those long-term adjustments continue quietly, not in a way that demands attention, not in a way that interrupts continuity. There is nothing here that requires readiness. Planetary change does not arrive like an alarm. It arrives like a slow adjustment that unfolds across generations. That kind of change leaves space. Space for systems to remain balanced. Space for moments like this one to pass without urgency. And when you become familiar with that rhythm, the idea of stability feels less like something that must be protected and more like something that naturally persists. Because stability at this scale is not about holding still. It's about moving in a way that has time built into it. Slow enough to remain predictable, gradual enough to remain steady. And as that sense of gradual motion settles in, it becomes easier to see how time itself shapes structure, how long durations give rise to regular paths, repeated motion, patterns that return again and again, which leads naturally to what comes next. The way slow time becomes organized motion, as the regular paths planets follow, and how those paths contribute to long-term stability. That slow rhythm we've been settling into doesn't just shape time, it shapes motion. When planets move through space, they don't wander randomly. They follow paths that repeat again and again. Not because those paths are perfect, but because they are consistent. Planetary orbits are not delicate arrangements. They are long-established patterns that persist across immense spans of time. Earth has been following its path around the Sun for billions of years. Not exactly the same way every single moment, but close enough to remain steady. Close enough to be predictable. That predictability doesn't come from precision. It comes from repetition. Each orbit builds on the one before it. Each cycle reinforces the next. Over time, small variations are absorbed. They do not accumulate into instability. They blend into the larger pattern. This is how regular motion works at a planetary scale. Orbits are continuous. They don't begin and end. They loop steadily without interruption. From one year to the next, Earth returns to roughly the same position. From 1 million years to the next, that pattern remains recognizable. That doesn't require constant correction. It doesn't require active adjustment. The motion sustains itself. When scientists measure planetary orbits, they don't find systems on the verge of falling apart. They find motions that have remained within familiar bounds for extremely long durations. That's an important distinction. Stability here does not depend on exact alignment. It depends on long-term regularity. Even when small shifts occur, the overall pattern remains. The orbit does not disappear. It continues. This is why repetition matters more than perfection. Perfect motion would be fragile, but repeated motion is resilient. Over time, repetition smooths out irregularities. It creates a rhythm that can persist. Earth's orbit has been repeating long enough to become reliable. Not because it never varies, but because variation is limited and spread out. That's what makes long-term stability possible. You don't need an orbit to be exact. You need it to return. Again and again. That returning motion is what allows seasons to repeat. It's what allows long-term climate patterns to exist. It's what allows the planet to remain within familiar ranges. None of this depends on delicate balance. It depends on endurance. Planetary orbits are measured across extreme durations because they last long enough to be measured that way. Millions of years, hundreds of millions of years. Those measurements show consistency, not rigidity, consistency. That consistency doesn't ask for attention. It doesn't respond to concern. It simply continues. As Earth moves along its path tonight, it is doing what it has done countless times before. Not faster, not slower. The motion is familiar at a planetary scale. It's easy to imagine orbits as narrow lines that must be followed exactly. But that isn't how they behave. They are ranges, patterns, paths that tolerate small variation without losing their overall form. That tolerance is part of what makes them stable. If orbits required exact precision, they would be fragile. But because they allow variation, they persist. Over time, repetition becomes structure. Each completed orbit reinforces the next one. Each cycle adds to a history of motion that has already proven sustainable. That history matters. It means the current motion is not experimental. It is not untested. It has been repeating long enough to be dependable. And that dependability doesn't require oversight. The planet does not need to be guided back onto its path each year. It does not need to be checked. The motion continues on its own. That's part of the calm built into planetary systems. Order without effort, regularity without tension. This kind of order does not feel strict, it feels settled, because it is built from repetition rather than control. When motion repeats across long spans of time, it becomes familiar. And familiar motion does not feel threatening. It becomes part of the background. As you rest, Earth completes another small portion of its orbit, a motion so gradual that it doesn't announce itself. And that quiet continuation is exactly the point. Stability here does not come from holding things in place. It comes from allowing motion to repeat again and again. Over very long periods, that repetition creates predictability, not the kind that demands attention, the kind that allows things to proceed without interruption. Planetary orbits don't rush, they don't hesitate. They move steadily through space, guided by long-established relationships. Those relationships are not new, they are not temporary. They have been in place long enough to support everything that depends on them. That's why stability doesn't feel tense at this level. It feels orderly. Order built from motion, from repetition, from time. And once you recognize that orbits are not fragile paths, but enduring patterns, it becomes easier to see how consistent motion supports balance, how steady movement across space contributes to long-term stability. Because when motion is regular, when paths repeat without interruption, balance has room to exist, and that balance extends further than motion alone. That repeated motion we've been describing doesn't happen in a small space. It unfolds across vast distances, and even there, the same regularity holds. Planetary orbits extend across millions of kilometers, yet their paths remain consistent. Not locked into exact positions, but contained within stable ranges. As Earth moves through space, its distance from the Sun changes slightly over time. Those changes are expected. They do not signal instability. A variation at this scale is normal. What matters is that those variations stay within familiar bounds, and they do. Over very long durations, orbital paths remain recognizable. They do not drift unpredictably. They do not suddenly reorganize. The motion stays organized across space. That spatial consistency is another layer of stability. It means that even as planets travel immense distances, their behavior remains reliable. The same general paths, the same repeated motion. Planetary systems are designed by their physical nature to tolerate variation. Small shifts in distance, minor changes in speed. Those differences do not disrupt the overall pattern. Instead, they are absorbed into it. Over time, these systems demonstrate a kind of flexibility that supports long-term balance. Not because everything is fixed, but because nothing needs to be exact. Exact positioning would be difficult to maintain, but stable ranges are much easier to sustain. Earth's orbit exists within such a range. That range has remained intact for billions of years, across enormous stretches of space. When scientists observe planetary motion, they don't see paths that must be constantly corrected. They see motion that naturally stays organized. That organization does not come from tight constraints. It comes from relationships that persist across distance. Those relationships hold even as planets move continuously. As Earth travels along its orbit, it covers a great deal of space. And yet, from one year to the next, its position remains a part of the same larger pattern. That pattern doesn't break down as distance increases. It remains consistent. This is important, because it means stability does not weaken with scale. It does not fade as space expands. The same principles that apply locally apply across larger distances. Motion remains structured. Paths remain recognizable. That consistency across space allows planetary systems to remain coherent over time. And coherence does not require stillness. It allows for movement, for variation, for gradual change, all within limits that support stability. As you rest, Earth is not confined to a small region. It is moving through a large spatial path that has been followed many times before. That path is not new. It is not experimental. It has been reinforced through repetition across both time and space. That reinforcement makes long-term predictability possible. Not because nothing varies, but because variation remains contained. Planetary systems are not disrupted by small differences. They are built to accommodate them. That tolerance is part of their strength. Across vast distances, motion remains orderly. Across long durations, patterns persist. This combination of temporal and spatial regularity is what allows stability to hold. It does not depend on precise positioning. It depends on continuity. As Earth moves, it stays within a familiar corridor of motion, a region of space where its behavior remains consistent. That region has existed for a very long time, and it continues to exist now. Nothing about tonight's position is unusual at a planetary scale. It fits comfortably within the established pattern. There is no sense of being close to an edge, no indication that motion is approaching a boundary. The system is not tight, it is spacious. That spaciousness allows motion to continue without tension. It allows orbits to remain stable even as planets travel great distances. And because of that, there is no need to track exact positions. No need to monitor each moment. The system remains balanced on its own. Spatial consistency reinforces temporal calm. The same steadiness we observe across long spans of time also appears across large spans of space. Together, they create a framework where stability is not fragile. It is durable, built from motion that repeats, across time, across space. As you lie here, Earth continues its movement along a path that has proven reliable over immense distances. That movement does not require awareness. It does not depend on attention. It is part of a system that has already settled into long-term regularity. And that regularity extends beyond motion alone. Because once time and space align into consistent patterns, they support deeper physical conditions that help maintain balance from within. That regular motion through space is only part of the picture. It explains how the planet moves, but not everything that keeps it steady comes from motion alone. Some of that stability comes from within. Earth is not held together only by its path around the Sun. It is also supported by its internal structure. That structure did not need to be designed. It formed naturally as the planet took shape. From the beginning, materials settled according to simple physical behavior. Heavier material moved inward. Lighter material remained closer to the surface. Over time, this led to layers, not sharp divisions, but gradual transitions. An inner region where mass is concentrated. Outer regions where material is less dense. This arrangement is not delicate. It is the expected outcome when a large amount of matter gathers under gravity. I once established that distribution remains largely consistent, not because it is locked in place, but because there is no reason for it to change quickly. The planet's mass stays where it is most stable, toward the center. That internal arrangement supports balance. It affects how the planet responds to forces, how it rotates, how it maintains its shape over long durations. None of this requires attention. None of it needs to be checked. The internal structure of Earth has been in place for billions of years, and during that time, it has remained within familiar bounds. Small adjustment can occur, gradual shifts over very long spans, but the overall arrangement persists. This is important because it means stability does not depend on constant motion alone. It also depends on what stays in place. The internal structure provides that steadiness. It gives the planet a kind of physical continuity that does not fluctuate from moment to moment. As Earth rotates and orbits, its internal mass distribution remains largely unchanged. It does not respond to short-term variations. That separation of timescales matters. Surface events can come and go. External motion continues, but inside, the structure remains steady. This internal consistency contributes to long-term balance. It means the planet does not easily lose its overall form. It does not suddenly rearrange itself. Large-scale changes take time, very long time, and that slowness supports stability. The way mass is distributed inside Earth is not a rare condition. It is typical for planets of this size. When material gathers under gravity, this is what tends to happen. There is nothing fragile about it. It does not require fine adjustment. It does not rely on exact placement. It is a broad, stable arrangement that tolerates variation. That tolerance allows the planet to remain steady even as it experiences gradual change. Nothing inside Earth is waiting for intervention. Nothing needs to be corrected. The internal processes that exist operate within ranges that have proven stable over immense durations. They do not react quickly. They do not respond to short-term signals. They continue at their own pace. That pace is slow enough to preserve continuity. From a planetary perspective, internal balance is the default, not something achieved with effort. It is simply how large bodies behave when they form and settle. As Earth formed, material organized itself in the most stable configuration available. And once it reached that state, there was no reason to move away from it. That configuration has supported everything that followed. Oceans forming, surfaces shifting, atmospheres developing. All of that took place on top of a structure that remained consistent underneath. That consistency does not require monitoring. You do not need to hold it together. You do not need to understand it in detail. The planet does not rely on awareness to maintain its internal balance. It has been doing so through long periods when nothing on the surface resembled the present, through eras without oceans, without continents as they are now, without life as we know it. And still, the internal structure remained within stable bounds. That tells us something important. Stability is not something added on later. It is something built in from the beginning. It arises naturally when matter settles over time. As you rest, nothing inside the planet is adjusting in response to you. Nothing is shifting because of this moment. The internal structure continues quietly, unchanged. That quiet persistence is part of what makes long-term balance possible. It allows surface conditions to exist without constant disruption. It allows motion and change to unfold gradually, supported from below. This is not a special condition. It is an ordinary one. Most planets that remain intact over long periods share this kind of internal consistency. Earth is not exceptional in this regard. It is behaving as large bodies tend to behave. That realization can be reassuring, because it means stability does not depend on perfect circumstances. It depends on natural outcomes that have already taken place. Those outcomes do not reverse easily. They persist, and because they persist, the planet remains steady, not only because of where it moves, but because of what it is. A body with mass arranged in a way that supports balance, a structure that has settled into long-term consistency. That internal steadiness supports everything else. Surface motion, external orbits, long-term patterns. And as we move forward, it becomes clearer how this internal balance works alongside other slow processes to maintain stability over time. Because inside the planet, just like outside it, things do not rush. That internal structure does more than hold mass in place. It also manages energy. Inside Earth, heat moves slowly, not in bursts, not in sudden releases. This heat comes from long-standing sources, energy left from formation. Energy released gradually by natural internal processes. None of this arrives quickly, none of it needs to. Thermal balance inside a planet works on long timescales. Heat moves from warmer regions toward cooler ones at a steady pace. That movement is regulated by physical properties that do not change from moment to moment. Material composition, density, distance. Because of that, internal temperature does not fluctuate rapidly. It changes slowly, incrementally. This gradual movement of energy is another reason planetary stability persists. If heat moved quickly, internal conditions would be volatile. But because it moves slowly, balance can be maintained. Earth does not build up internal energy and then release it suddenly. Instead, energy is transferred over long durations. That transfer does not require control. It does not require monitoring. It happens because of how matter behaves under consistent conditions. Thermal balance is not an active process. It does not switch on or off. It continues steadily whether anyone is aware of it or not. This is important because it means internal regulation does not depend on precise timing. It does not respond to short-term variation. It unfolds according to physical behavior that has remained consistent for billions of years. Heat inside the planet moves at rates that are slow enough to preserve structure, slow enough to avoid sudden change. Over time, this allows internal conditions to remain within stable ranges. Those ranges are broad. They tolerate variation. Small differences in temperature do not disrupt the system. They are absorbed and redistributed gradually. This redistribution takes time, and time here is an advantage, because when energy moves slowly, it does not overwhelm surrounding structures. It integrates smoothly. As a result, internal processes remain calm. They do not escalate. They do not require intervention. The planet does not need to be adjusted to maintain thermal balance. It does not need to be guided. The same physical rules that governed internal heat millions of years ago govern it now. Those rules do not change with attention. They do not react to concern. They continue at the same pace. That continuity contributes to the overall steadiness of the planet. External motion and internal structure work together. Slow orbits, stable mass distribution, gradual energy movement. Each supports the others. None of them operate on urgency. The internal thermal processes unfold independently of what happens on the surface. They are not influenced by short-term conditions. This separation allows surface environments to exist without constant disruption. Internal heat provides long-term consistency without sudden shifts. And because of that, the planet does not swing between extremes. It remains within ranges that support continuity. Thermal regulation does not need to be precise. It needs to be steady, and it is. Over very long spans of time, this steadiness allows internal conditions to adjust without instability. Energy moves, but it moves slowly enough to maintain balance. That slowness is not a weakness, it is a stabilizing feature. When processes take time, they do not overwhelm systems, they integrate. As you rest, nothing inside Earth is changing rapidly. Nothing is approaching a threshold. Internal conditions remain well within long-established patterns. Those patterns have supported the planet through extended periods of change, through shifts that unfolded gradually, through transitions that took millions of years. At no point did the internal system require immediate action. It continued quietly. That quiet continuation is part of what makes stability feel effortless at the surface. You are not resting on something that requires constant adjustment. You are resting within a system that regulates itself naturally. Internal heat moves, but it does so at a pace that preserves balance. Nothing needs to be watched. Nothing needs to be corrected. Thermal regulation is already in place. It has been in place long enough to be dependable. That dependability does not depend on perfect conditions. It depends on duration, on processes that have had time to settle into consistent behavior. This is how large systems tend to behave. They do not rush, they do not react sharply, they operate within broad, stable ranges. Internal structure provides support, thermal balance provides regulation. Together, they allow the planet to remain steady over long durations. This steadiness is not fragile. It does not require protection. It persists because of ordinary physical behavior. As you breathe slowly, nothing inside the planet responds. Nothing adjusts in reaction. Internal processes continue at the same pace they always have. That independence is reassuring, because it means stability does not rely on awareness. It does not depend on attention. It is already established. And with that understanding, the picture becomes clearer. External motion, internal structure, thermal regulation, all operating together, all unfolding slowly. This combination creates stability that does not feel tense. It feels settled, and from here, it becomes possible to see how these layers, time, motion, structure, and energy fit together. How they form a system that maintains balance without urgency, which leads naturally into the deeper understanding that comes next. When we step back and look at everything together, a pattern begins to stand out. Not something dramatic, not a sudden realization, something steadier than that. The forces that hold a planet in place are not constantly struggling to keep things together. They are not fighting against collapse. They have already settled. Gravity is one of those forces. It does not arrive suddenly. It does not turn on and off. It acts continuously. From the moment a planet forms, gravity begins shaping relationships between the planet and its star, between the planet and its own material, between motion and mass. Over time, those relationships adjust, not through sharp corrections, but through long-term interaction. When a planet enters orbit around a star, the motion does not need to be perfected. It needs to repeat. And as it repeats, gravitational forces smooth the behavior of the system. Small differences in motion are distributed. Irregularities are averaged out. What remains is a pattern that can persist. That persistence is what matters. Gravitational balance does not depend on exact distances measured to infinite precision. It depends on ranges that have proven stable across time. Earth's relationship with the Sun has existed long enough to demonstrate that stability, not once or twice, but across billions of repetitions. Each orbit reinforces the next. Each cycle confirms that the balance holds. That is not coincidence, it is endurance. Gravitational systems that do not settle tend not to last. They change until they find configurations that can persist. The systems we observe today are the ones that have already done that settling. They are here because they work. That idea changes how stability feels. It is not something rare, it is something selected by time. Over long durations, unstable arrangements fade. Stable ones remain. That is why planetary systems look calm when observed across millions of years. The gravitational relationships that support them are not fragile. They have already passed countless tests. Earth does not need gravity to behave perfectly every moment. It needs gravity to behave consistently over time. And it does. The strength of gravitational interaction does not fluctuate wildly. It does not respond to short-term variation. It follows the same physical behavior now that it has always followed. That consistency allows motion to remain predictable, not exact. Predictable, and predictability is enough. When gravity acts over long spans, it does not need to be corrected. It does not need supervision. It shapes motion naturally. Planetary paths settle into patterns that can endure. Those patterns persist because nothing is pushing them out of balance quickly. Change, when it occurs, happens gradually. As a result, gravitational balance feels quiet. It does not announce itself. You do not feel gravity working moment by moment to hold the planet together, because it does not need to. It has already established a relationship that functions over long durations. This is where the idea of stability shifts. Instead of seeing stability as something constantly defended, it becomes clear that stability is often the outcome of time. Time allows systems to adjust, to discard what does not work, to reinforce what does. Gravitational balance is one of those reinforced outcomes. Earth's orbit remains stable not because it is delicately arranged, but because it has settled into a configuration that does not require constant change. The distance between Earth and the Sun varies slightly over time. That variation is expected. It does not threaten the system. It is part of it. What matters is that those variations remain within a range that has proven sustainable, and they do. That range has held across ice ages, across changes in surface conditions, across shifts that took millions of years. Through all of that, the gravitational relationship remained intact. That tells us something important. Stability is not maintained by resisting all change. It is maintained by accommodating change gradually. Gravity does not force systems into rigidity. It allows flexibility within limits. That flexibility is why balance lasts. Over time, gravitational systems tend to find configurations that absorb variation rather than amplify it. That absorption is what prevents sudden disruption. It means that small influences do not accumulate into instability. Instead, they are spread out across time. This is why long-term gravitational balance does not feel tense. It does not rely on constant correction. It does not require attention. It exists because the system has already demonstrated that it can persist. As you rest, gravity is not doing anything new. It is not adjusting to the present moment. It is continuing a behavior that has been steady for billions of years. The same forces that guided Earth's orbit long before now are guiding it still. They do not hurry. They do not hesitate. They act at the same pace they always have. That pace allows balance to remain intact. Gravitational stability is not a rare condition that must be preserved carefully. It is the default outcome when systems are given enough time to settle. Planetary systems that last are the ones that have already reached that state. Earth is one of them. That does not mean nothing can ever change. It means that change usually unfolds within a framework that remains stable. Gravity provides that framework. It holds motion within predictable bounds. It keeps relationships intact across distance and time. Because of that, surface conditions have room to exist. Oceans can persist. Atmospheres can remain. All of that depends on gravitational balance that does not fluctuate suddenly. And that balance does not require vigilance. It is already established. Over time, gravitational interactions create systems that are resilient rather than fragile. Resilient because they have absorbed variation repeatedly and remained intact. This resilience does not feel dramatic. It feels ordinary, which is why it often goes unnoticed. But it is one of the most important reasons stability persists. The Earth's gravitational relationships are not holding on by a narrow margin. They are operating within broad ranges that have proven reliable. Those ranges allow motion to continue without tension. As you lie here, the planet remains within those bounds. Nothing is approaching a limit. Nothing is being forced. The system is not balanced on a fine edge. It is settled. That is the quiet twist in all of this. Stability is not something rare that occasionally appears. It is what remains after time has done its work. Systems that endure are the ones that settle into balance. Gravity does not need to be perfect. It needs to be consistent. And consistency over time is enough. This is why planetary stability does not require constant attention. It does not need to be defended. It has already been established through long-term behavior. Once you see stability this way, it becomes less abstract. It becomes something that is already present, not a temporary condition, not a fragile one, but a natural outcome of time, motion, and balance working together. And from here, it becomes easier to understand how that same long-term balance extends beyond motion itself, supporting the conditions we experience at the surface. Because gravitational stability is only one layer, it sets the stage for everything that rests upon it. Rotation adds another layer to the picture, not as something dramatic, not as a force that demands attention, just as a constant. Earth has been rotating for a very long time, long before there were surfaces like the ones we know now, long before any familiar landmarks existed. That rotation did not need to be established carefully. It emerged naturally as the planet formed. Once it began, it continued, not at a pace that fluctuates from day to day, not in a way that requires adjustment. The rotation remains steady over long spans of time. That steadiness matters because rotation helps distribute energy. It shapes how internal and surface processes unfold. And like everything else we've talked about, it does so gradually. The length of a day does not change abruptly. It shifts slowly across immense durations. Those shifts are measured across millions of years, not across nights. From one day to the next, the difference is negligible. From one lifetime to the next, it is imperceptible. That slow pace allows continuity. Rotation provides a regular rhythm, not a rigid one. A rhythm that has room for gradual change without disruption. As Earth turns, it does so with consistency. That consistency does not depend on precision. It depends on persistence. The planet does not need to spin at exactly the same rate every moment to remain stable. It needs to remain within a range that has proven sustainable. And it does. That range has supported long-term balance for billions of years. Rotation works alongside internal processes rather than competing with them. Inside the planet, energy continues to move slowly. We talked about how heat travels gradually, regulated by material properties. Rotation does not interfere with that. It complements it. Together, these processes create a system where change unfolds evenly. Internal heat does not surge suddenly. Rotation does not fluctuate rapidly. Both operate on timescales that allow adjustment without urgency. This is another reason planetary systems feel calm when viewed across long durations. Nothing is rushing. Internal regulation unfolds quietly. Energy moves where it needs to move slowly. Rotation continues at a steady pace. Neither process needs to be managed, neither needs intervention. They persist because they are stable configurations. Over time, unstable rotational patterns do not last. They change until they settle. The ones we observe today are the ones that have already done that settling. Earth's rotation has passed that test. It has remained within a stable range long enough to support everything built upon it. That includes internal structure, thermal balance, surface conditions. None of those would persist if rotation were erratic, but it isn't. It is predictable. Predictability does not mean sameness. It means continuity. Rotation allows the planet to experience cycles, repeated sequences that unfold reliably. Those cycles are not abrupt, they are gradual. They do not require attention to continue. As Earth rotates tonight, nothing inside it needs to adjust in response. Internal processes remain steady. Energy continues to move at the same pace it has for a very long time. Rotation does not interrupt internal regulation. It does not amplify variation. It supports balance by distributing effects evenly over time. This combination matters. Slow internal regulation prevents sudden change. Steady rotation prevents uneven buildup. Together, they create consistency. Consistency does not feel exciting. It feels reliable. And reliability is what allows long-term stability. Planetary systems that endure are the ones where these processes align. rotation that remains steady, internal regulation that unfolds gradually. Neither needs to be exact, both need to persist. Earth meets those conditions. That does not require constant correction. It does not require monitoring. It simply continues. As you rest, the planet completes another fraction of a turn. So small, it does not announce itself. Inside, heat continues to move at its own pace, not faster, not slower. Those processes are not synchronized to this moment. They are part of much longer sequences. That separation from the present moment is reassuring. It means nothing depends on this night unfolding a certain way. The systems supporting stability are not sensitive to short intervals. They are shaped by repetition across long spans. Rotation repeats. Internal regulation continues. Both have done so long enough to become dependable. Dependability here does not come from control. It comes from duration. Processes that have unfolded steadily for billions of years do not require vigilance. They are already established. This is why stability does not feel tense at a planetary scale. It is not something that must be maintained moment by moment. It is something that has emerged naturally from how larger systems behave over time. Rotation provides rhythm. Internal processes provide regulation. Neither is hurried, neither is fragile. They operate within broad ranges that allow flexibility without loss of balance. That flexibility is important. It means the system can accommodate gradual change without losing continuity. Small variations do not accumulate into disruption. They are absorbed. Over time, the overall behavior remains recognizable. That recognition is what allows scientists to describe planetary behavior confidently across long durations. Not because they expect nothing to change, but because they understand how slowly change unfolds. Rotation and internal regulation work together to ensure that slowness. They spread effects out across time. They prevent concentration. This is another way stability becomes the default. Not because nothing happens, but because what happens takes time. As you lie here, there is no process inside the planet accelerating, no rotation speeding up. Everything continues at the same pace it has for ages. That constancy allows surface conditions to remain within familiar ranges. It allows environments to persist. It allows moments like this one to exist without urgency. Nothing about rotation demands awareness. Nothing about internal regulation requires attention. They continue whether or not they are noticed. That independence is reassuring because it means stability does not rely on observation. It does not depend on understanding. It simply exists. Rotation, heat, structure, all moving slowly, all regulated naturally. This layered continuity supports everything that follows, and with that foundation in place, it becomes easier to see how these deep processes shape what we experience more directly. How surface conditions emerge from long-term stability. Because the planet does not need to be hurried to remain steady. It already is, and that steadiness carries forward into the environments that form above it. All of that stability beneath the surface makes something else possible. Something closer to where we are. It allows surface conditions to remain within familiar ranges, not because they are fixed, but because they are supported by many slow processes working together. At the surface, change is visible. Land shifts, water moves, air circulates. And yet, across deep time, certain broad conditions persist. Temperatures fluctuate, but within limits. Atmospheres change, but not all at once. Oceans expand and retreat gradually. None of this happens suddenly. Surface conditions are shaped by layers of influence: internal structure, rotation, orbital motion, energy balance. Each contributes a small part. Together, they create continuity. This continuity does not require the surface to be perfectly stable at every moment. It requires conditions to remain within ranges that can support persistence. And they do. Over long spans of time, Earth's surface has experienced variation, but that variation has been spread out. Changes arrive gradually. They overlap rather than collide. This overlapping behavior is important. It prevents extreme shifts from dominating. It allows adjustments to balance one another. When one factor changes slowly, others respond slowly as well. Nothing moves fast enough to overwhelm the system. Surface conditions are not held in place by a single mechanism. They are supported by many processes unfolding together. Each one operates on its own timescale. None of them rush. Energy arrives from the sun at a steady rate. The planet rotates, distributing that energy evenly over time. Internal heat contributes gradually. Atmospheric movement responds continuously. Water cycles repeat. These processes are familiar. They do not announce themselves, and because they repeat, they create patterns that persist. This is how surface environments remain recognizable across deep time, not because nothing changes, but because change is shared. It is distributed across processes and across time. When surface conditions shift, they do so incrementally. That incremental behavior leaves room for stability. It allows the surface to adjust without crossing into extremes. The idea of habitability is often framed as something fragile, but from a long-term perspective, it is supported by endurance. Endurance built from many slow processes overlapping. None of those processes need to be precise. They need to be consistent, and consistency is what we see. Surface conditions have remained within broad ranges long enough for continuity to exist. Not because of careful management, not because of constant correction, but because the underlying systems operate slowly. When systems move slowly, they are less likely to overshoot, less likely to drift abruptly. They remain within bounds. This is why surface conditions do not require vigilance. They are not balanced on a narrow edge. They exist within wide regions of possibility that support persistence. Over time, surface environments respond to gradual change by adjusting gradually. There is no need for sudden shifts. The planet does not jump from one state to another overnight. Instead, conditions evolve across long durations. That evolution is calm. It does not compress into moments of urgency. As you rest, nothing about the surface environment is approaching a threshold. Nothing is nearing a sudden transition. The systems shaping surface conditions continue at their usual pace. Air moves, water cycles, temperatures fluctuate gently. These processes do not require monitoring. They do not depend on attention. They have been repeating long enough to become dependable. Surface stability is not a single condition. It is a pattern formed by many influences acting together. Internal processes provide support. External motion provides rhythm. Surface interactions distribute effects. Each layer contributes. And because they are layered, no single process dominates suddenly. This layering creates resilience. If one influence changes slightly, others absorb the difference. The result is continuity. Surface conditions remain within ranges that allow familiarity, not frozen, not rigid, familiar. That familiarity is reassuring, because it means the environment you experience is not temporary. It is part of a long sequence, a sequence that has accommodated variation many times before. Earth's surface has persisted through shifts that unfolded over millions of years, through gradual changes in composition, through slow rearrangements. And still, the basic conditions remained. This does not require perfection. It requires time. Time allows processes to balance one another. Time allows variation to be integrated rather than amplified. Surface stability emerges from that integration. As you lie here, the surface of the planet is not doing anything unusual. It is behaving as it usually does. Changes continue, but they are not urgent. They are part of ongoing cycles. Those cycles have no endpoint that approaches suddenly. They unfold steadily. This steadiness is not dramatic. It is quiet. And because it is quiet, it often goes unnoticed. But it is one of the reasons surface environments persist. The planet does not need to hold itself rigid to remain stable. It allows movement, movement that repeats, movement that balances. Surface conditions reflect that balance. They are not fragile states waiting to collapse. They are durable outcomes of long-term behavior. Durable because they have been reinforced repeatedly, through time, through motion, through structure. As you rest, nothing about the surface environment requires correction. Nothing is being pushed beyond its range. The systems that support surface conditions are already in place. They have been operating long enough to be reliable. That reliability does not come from control. It comes from persistence, and persistence, at this scale, is ordinary. The planet has had time to settle into patterns that work. Surface conditions are part of those patterns. They extend the stability we've been describing from deep inside the planet all the way to the environment you experience. This is not a special moment. It is a continuation of long-term balance. And once you see surface stability as an outcome rather than an exception, it becomes easier to relax inside it. Because nothing needs to be held together right now. Nothing needs to be protected. The conditions around you are supported by layers of slow, steady processes that have already proven their endurance. That understanding does not demand attention. It does not require action. It can simply settle in. And from there, the picture becomes whole. Time, motion, structure, energy, environment, all aligned into a system where stability is not rare. It is what remains, which is where the emotional synthesis begins. When you take all of this together, one final pattern becomes clear. It's one that often gets missed when we think in short spans. Sudden change is not the usual way planets behave. That doesn't mean change never happens. It means that when change occurs at planetary scales, it almost always unfolds slowly. This is not a hopeful idea. It's an observational one. Large systems change differently than small ones. The more mass involved, the more time it takes for that mass to respond. The more layers a system has, the more gradual its adjustments tend to be. Earth is a large system. Its motion, structure, energy flow, and surface conditions are all connected. Because of that, no single influence can move everything at once. Change has to pass through layers. When something begins to shift, it does not propagate instantly. It moves gradually, moderated by other processes already in place. This is why abrupt, system-wide change is uncommon. It is not forbidden, it is simply difficult. For a sudden change to affect the whole planet, many independent processes would need to align at the same time. They would need to overcome inertia. They would need to move faster than their natural pace. Most of the time, that does not happen. Instead, change spreads out. A shift begins in one place or process. Other processes respond slowly. Effects are redistributed. This redistribution reduces extremes. It prevents sharp transitions from dominating. That is why planetary history is mostly composed of long stretches of continuity, not constant disruption. When scientists look back across deep time, they do not see a record of endless instability. They see extended periods where conditions remain within familiar ranges. Changes occur, but they are layered into the timeline. They do not arrive all at once. This gradualism is not accidental. It is the natural outcome of physical systems operating at scale. Energy moves slowly. Mass resists rapid acceleration. Motion averages out variation over time. All of these factors work together to limit how fast change can occur. Predictability emerges from that limitation, not predictability in every detail. Predictability in behavior. The planet does not respond sharply to short-term fluctuations. It responds over time. That response time acts as a buffer. It gives systems room to adjust without crossing into extremes. This is why planetary stability does not depend on perfect conditions. It depends on time. Time allows processes to interact, to counterbalance one another. When one influence increases slightly, others adjust gradually. No single factor dominates instantly. This makes sudden, global change rare. It does not eliminate change. It shapes how change unfolds. From within the system, this feels like steadiness. There is no signal that something must happen immediately. No sense that balance is about to be lost. The planet does not rush. That is why thinking in short-term terms can create unnecessary concern. Short spans exaggerate contrast. They compress gradual trends into moments. But planetary systems do not experience time that way. They experience it as continuity, long durations where small changes accumulate slowly. When those accumulations become noticeable, they have already unfolded across vast spans. There is no sudden crossing point that arrives without warning. Change announces itself through duration. That does not require vigilance. It does not require constant monitoring. It simply unfolds. As you rest, nothing about the planet is approaching an abrupt transition. Nothing is converging toward an immediate shift. The systems we have been describing do not behave that way. They are not balanced on a narrow edge. They operate within broad ranges that absorb variation. This is why extreme change, when it does occur, is typically preceded by long periods of adjustment. Even then, those adjustments unfold slowly. Planetary change is cumulative, not impulsive. That distinction matters because it means this present moment is not carrying hidden urgency. Nothing is being decided tonight. The conditions that support stability are not waiting to fail. They are not approaching a limit. They have already accommodated variation far beyond what a single moment can introduce. This understanding allows concern to release, not because nothing ever changes, but because change is not sudden. It is gradual, predictable in its pace. Predictability here does not mean control. It means familiarity. The same processes that governed the planet long ago govern it now. They have not suddenly shifted into a different mode. They continue at the same rates. This consistency makes planetary behavior understandable across deep time. It allows scientists to reconstruct the past and anticipate the future without assuming abrupt transitions. That confidence comes from observation, from seeing how slowly large systems respond, from recognizing that sudden change is not the default. Stability is. That does not require optimism. It requires perspective. When perspective expands, urgency diminishes. Short-term thinking narrows focus. Long-term thinking restores balance. At planetary scales, balance is achieved through patience, through processes that take time, and because of that, there is no need to stay alert for sudden shifts. Nothing demands immediate response. The planet does not need to be watched closely to remain stable. It is already behaving in the way large systems usually do. As you lie here, the same slow processes continue. Motion repeats. Energy moves gradually. Structures remain intact. Nothing accelerates. Nothing converges suddenly. That absence of urgency is real. It is built into how planetary systems function. Recognizing that allows the nervous system to settle, because the environment is not unstable. It is not precarious. It is supported by layers of gradual behavior that resist sudden change. This does not mean nothing will ever be different. It means difference arrives slowly. Slowly enough to be integrated. Slowly enough to preserve continuity. That is the quiet resolution here. Stability is not something briefly achieved between disruptions. It is the dominant condition. Change happens within it, not against it. When you stop expecting sudden shifts, attention softens. You don't need to anticipate what comes next. The planet will continue doing what it has done for a very long time. And that understanding does not need to stay in the foreground. It can recede. It can become background knowledge, something that supports rest rather than demands thought. Because once you accept that sudden change is rare at this scale, there is nothing left to brace for. Only continuity, only gradual motion, only the steady unfolding of systems that have already proven their endurance. And with that, the sense of concern has room to release. Not through effort, not through reassurance, but through understanding. A quiet understanding that stability is not fragile. It is the default, and it is already in place. You followed this long path of ideas gently, without needing to hold on to them, without needing to remember every detail. And now, it's enough to let them settle. What matters is simple. The planet beneath you is stable. Not temporarily, not by effort. It is stable because it has been behaving this way for a very long time. Time, motion, structure, energy, environment, all of them continue together. Nothing about that system requires attention right now. Nothing needs to be checked. Nothing needs to be maintained. The same conditions that supported this moment before you arrived in it will continue after you drift away from it. You don't need to stay alert to remain safe here. You don't need to keep thinking in order for stability to hold. The systems we've talked about are not sensitive to awareness. They do not depend on correct understanding. They continue whether they are noticed or not. As you rest, Earth continues along its path. Not hurried, not delayed. Its rotation remains steady. Its internal processes remain regulated. Surface conditions remain within familiar ranges. Nothing is waiting for instruction. This is not a fragile arrangement. It is not something that must be preserved carefully. It is the natural state of a large system that has had time to settle. You are resting inside that settled state. There is no requirement to do anything with this understanding. You don't need to apply it. You don't need to carry it forward. It can simply exist in the background. The planet does not expect participation. It does not require effort. You can let your body respond to that. Let your shoulders lower a little. Let your breathing slow on its own. Nothing will be missed. Stability is not something that appears briefly between moments of risk. It is what remains when systems have had time to organize themselves. Earth is one example of that. Not exceptional, not precarious, just steady. And that steadiness extends through this moment, through the ground beneath you, through the air around you. You are not resting on something uncertain. You are resting within a system that has been functioning continuously through changes far slower than a single night. Nothing is about to shift suddenly. Nothing is approaching a threshold. There is no need to anticipate what comes next. The planet does not move in response to short intervals. It responds across long spans. That means this moment is not carrying extra weight. It does not need to resolve anything. You can let your attention loosen. Thoughts can slow without consequence. Awareness can drift. Stability does not require clarity. If ideas fade, nothing important is lost. The processes supporting this moment are not fragile. They do not rely on vigilance. They have already proven their endurance. Time has already done its work. As you rest, the same slow patterns continue. Motion repeats. Energy moves gradually. Everything stays within ranges that support continuity. There is a quiet comfort in knowing that nothing needs to be held together right now. Nothing is being balanced on a narrow edge. The environment you are in is not temporary. It is part of a long sequence. That sequence does not hurry. It does not compress itself into urgency. It unfolds at its own pace, and that pace allows rest. You don't need to remain awake to understand any of this. Understanding is optional. The planet will continue behaving the same way whether you are thinking about it or not. That independence is reassuring. It means you can let go. If your thoughts begin to wander, that's fine. If they become quieter, that's fine too. Nothing needs to be decided. Nothing needs to be planned. This moment does not require readiness. The systems beneath you are not asking for response. They are already operating within long-established patterns. You can trust that. not as an act of belief, but as an observation. Stability is not something that needs to be earned. It is something that emerges naturally when time is allowed to pass. Earth has had that time, and tonight, that same long-term balance is still in effect. You are not outside of it. You are part of it. There is nothing you need to do to remain where you are. If sleep comes, it can come naturally. If rest deepens, it can deepen without interruption. Nothing will change because of that. The planet does not require awareness to continue. It does not respond to attention. It simply persists. You can allow that persistence to support you. Let the idea of effort recede. Let concern soften. This is not a moment that demands alertness. It is a moment that allows rest. If you continue listening, the tone can remain gentle. If you drift away, that's just as welcome. Nothing depends on staying present. The stability we've talked about does not fade when attention fades. It remains, and that's enough. You can let your body settle into that understanding, not actively, just by allowing it. Breathing continues, motion continues. Everything proceeds at its usual pace. There is no rush here, no urgency hidden beneath the surface, just continuity. Long-term patterns unfolding quietly. You don't need to follow them any further. They will continue on their own. And as this moment comes to a close, nothing needs to change. You can rest knowing that the system supporting you is not temporary. It has been here for a very long time, and it will still be here when this moment passes. If you choose to keep listening, you can do so calmly. If you choose to sleep, you can let that happen without thought. Either way, nothing requires attention now. You are resting inside a stable system. That stability does not need to be reinforced. It does not need to be remembered. It simply remains. And with that, you can allow yourself to rest fully, without effort, without vigilance. Just rest